So any first order first degree differential equation uh, can be written as dy dx equals to f of xy. There is another format of this. We can also write first order first degree differential equation in this way, where m and n are both function of x and y. Okay. So this differential equation is said to be an exact equation if we can write this equation in this format. Okay. So for an example, if I give you this differential equation x dy plus y dx equals to 0. So we can write this equation in the form of d of xy equals to 0. Okay, and directly integrating this equation, we can find the solution, general solution of this differential equation. It will be xy equals to c, where c being an arbitrary constant. Okay, let me take another example. So if I give you log x dy plus y by x dx equals to 0, we can easily solve this differential equation. We can also write this differential equation in this way: d of y log x equals to 0, and directly integrating this equation, we will get y equals to log of x equals to c. Again, the c is an arbitrary constant. Okay. So if there is any equation, if this equation can be written in this format, then we can say this equation is an exact equation. Okay. So there is a theorem. It says that the necessary and sufficient condition for differential equation this m dx plus m dy equals to 0 to be an exact equation if del m del y equals to del m del x. The del m del y is basically partial derivative of m with respect to y. So let me explain how to calculate partial derivative. It's basically this m and n. I already told you that m and n are both function of x1. Okay. So for an example, suppose there is a function x square y plus y square into x cube. Okay, suppose you want to derivative this partially with respect to x, then this y behave like a constant. Okay, then the derivative will be 2xy plus 3x square y square. And in a similar manner, if I derivative this partially with respect to y, it will be x square plus 2y into x cube. Okay, I hope the partial derivative is clear, how to calculate partial derivative. So it say that if there is any exact equation, then it definitely follow this condition: del m del y equals to del m del x. Okay, so we can also prove this. The proof is not that much important, but let me explain why this. Okay, So suppose there is a differential equation, first order first degree differential equation, m dx plus n dy equals to 0. Okay, so by the definition we know that if this equation is an exact equation, then we can write this differential equation in the format of d. Okay, so we can write del m del x plus n dy equals to du. It's basically total derivative of u. Okay, and if you have the basic idea of calculus, we know how to calculate total derivative. It's basically del u del x into dx plus del u del y into dy. Okay, dy. So if we compare this equation, means from right hand side with left hand side, we can write m equals to del u del x and n equals to del u del y. Okay, so now if we derivative m with respect to y, it will be del m del y del 2u del y del x. And since u is a continuous function, we can write del u del 2u del x del y. For a continuous function, this two value it will be same. Okay, so instead of del u del y del x, we can write del 2u del x del y. In a similar way, if we partially derivative in with respect to x, it will be del 2u del x del y. Okay, so therefore we can say del m del y equals to del n del x. Okay, so in this way we can prove this condition, but the proof is not important. Now try to understand how to apply this result to check any given differential equation is exact or not. Okay, so for an example, let me take this example. E to the power x sin y dx plus e to the power x plus 1 cos y dy equals to 0. Okay, so let me take this is equation number 1. So if you compare this equation with m dx plus n dy equals to 0, we can easily say the value of m is e to the power x sin y, and here m is e to the power x plus 1 cos y. Okay, now derivative this m with respect to y, it will be e to the power x cos y, and if we derivative m partially with respect to x, it will be e to the power x cos y. Okay, so therefore del m del y del n del x. So we can say that the equation 1 is an exact differential equation. Try to solve other problem and check the any given differential equation is exact or not. Okay, so in next video I will explain if there is a differential equation given and suppose it is not exact, then how to solve those differential